Okay, in this video we'll talk about the Laplacian operator. So here we have the Laplacian operator, which is represented as an upside down delta, which is partial squared over partial x squared plus partial squared over partial y squared plus partial squared over partial z squared. So it's basically the second derivative, second partial derivative in all three directions, or as many directions as you have. It can also be represented as delta dot delta, which is the same thing as delta squared. In two dimensions, the Laplacian of a function f then becomes the partial square f over partial x squared plus partial square f plus partial y squared. So what is the real effect it has? Here's the original function or object. Its first derivative, we see that it basically has peaks at the zero crossings, and its second derivative, we see it has a double peak, a positive and a negative peak around each of the zero crossings. And why is this useful? As you can see, it can figure out where the edges of a system are. It's great for edge detection in images. So here we see the Laplacian of the Gaussian function, and we can see how it creates edges at certain thresholds based on however far from the Gaussian you want to be. And down here we see, just see the Laplacian of a function, which we've seen before. So what does it do in image recognition to images? Here we have a grayscale house, and as you can see, we've detected the edges of the house. Here we have some kind of a bird, and we first make it a grayscale image, and then we can detect the edges clearly. And here we have the edges of a cow in the forest. And this is just the same thing as the previous diagram. It's showing you how the various derivatives represent themselves. And when we do image processing, it's often used in a discretized way. So the Laplacian operator is represented by this matrix here. And if you include the diagonals, it's the second one here. So this matrix is what's used when we discretize the Laplacian to solve the equation. And this is the Laplacian of phi for review. So we have partial square phi over partial x squared plus partial square phi over partial y squared. And this is the original slide we started with. So now you understand how to use the Laplacian in image recognition, and you understand what the Laplacian is. And good luck in its usage. It's also used in electromagnetics, quantum physics, etc.